today we are going to see Unit 3, where the first topic is Hopfield network. First topic is Hopfield network, which is one of the classification of recurrent neural network. It is one of the classification of recurrent network. What is meant by a recurrent network? We have already seen in second unit. So let us consider x1, x2 or the two inputs which are transmitted through two weights of w1, w2, and this information is fed to a summation block, and then what is the output at summation block? Here the input that is obtaining at summation, first input is x1 into w1, second input is x2 into w2 plus a bias, let it be 0. Now x net at the output of summation is x1 w1 plus x2 w2, which is output of summation. Now it is passed through an activation function, let it be a step activation function. So by comparing this x net with 0, if this is greater than or equal to 0, you will get output as 1. Now if it is less than 0, you will get output as 0. So let this x net is greater than or equal to 0 and you are getting output as 1 from the neural network. This is basically feed forward neural network. Now what is meant by a recurrent neural network, which it is also known as feedback network. So recurrent is a feed forward plus a feedback network. Nothing but whatever may be the output you are getting at the output side, that is being sent as one of the input at the input. So this y, which is 1, is again sent as one of the input to the input through the weight of w1 dash and through the weight of w2 dash. Now what will you do? Again you will calculate x net. So at first input you are getting two inputs. One is x1 w1 is the first input. So at first input you are getting x1 w1 plus in addition to that you are getting y into w1 dash at first input. Now at second input x2 w2 plus y into w2 dash. So this is obtained as first input, this is obtained as second input. Now this input is obtained at the two inputs of summation block. Now adding, as these are the inputs for the summation block, we need to add the two inputs at the summation block. So what is x net now? The first input x1 w1 plus y w1 dash plus second input x2 w2 plus y into w2 dash. So this is the total net value obtained as the output of summation. Now this x net will be compared with again 0. If the condition is satisfied, you will get output as 1, if not 0. Let us consider the condition is not satisfied. So we are getting output as 0. Now this output of y, which is 0, is fed as one of the input to again the two inputs of network. Again we need to perform computation at first input, which is x1 w1 plus what is y? You are getting output as y as 0. So 0 into w1 dash, you get 0. This is first input. Now what is input at second input? x2 w2 plus 0. So what is x net? This is your x net. Now this x net is fed as an input to again the two inputs. So again this x net will be compared with activation. Let us consider the condition is satisfied. You are getting output y as 1, which is fed as one of the input for the two inputs. Again we will perform computation. Let us perform computation. So x1 w1 plus y is 1 into w1 dash. At second input x2 w2 plus w2 dash. Now what is x net? So this is x net. x1 w1 plus w1 dash plus x2 w2 plus w2 dash. So this is the output of summation. Now again it is compared with activation. If the condition is satisfied, you will get output as 1. If not, you will get output as 0 based upon that. Again it is fed as one of the input to both the inputs with some weights. So here if you see, this is called as a recurrent network or feedback network. It is a combination of, there is operation of feed forward plus also there is an operation of feedback. So it is a combination of feedback plus feed forward network. So this is a recursion process and this will be done until your actual output or target output is equal to y or your error is 0, which is equal to target minus actual. Until this condition is satisfied, you will perform this recurrent operation or you will perform the numerical computation at the output of load. So this is called as recurrent network. Now coming to the Hopfield network, Hopfield you will have n number of types in recurrent network, where Hopfield is one of the type of recurrent network. So coming to Hopfield, within the Hopfield you are having two types of classifications. Hopfield is of two types. Continuous Hopfield network, discrete Hopfield network. What is continuous Hopfield network? If continuous type of activation functions are used, it is called as continuous Hopfield network. If discontinuous activation functions are used, this is called as discrete neural network. What is continuous Hopfield network? If continuous activation functions are used. Examples are sigmoidal, unipolar sigmoidal and bipolar sigmoidal are the examples of continuous activation functions. Coming to discontinuous activation functions, step and binary activation functions comes under discrete activation functions. So if continuous activation functions like sigmoidal activation functions are used in Hopfield network, even at the hidden layer or even at the output layer, that is called as continuous Hopfield network. If discrete Hopfield networks like step or binary activation functions are used, that type of network is called as discrete Hopfield network. So those are the two types of classifications. But architecture of the neural network and also numerical computation at each layer, either that can be hidden layer or that can be output layer, numerical computations will be same for the Hopfield neural network. Either that can be continuous Hopfield network or that can be discontinuous Hopfield network. Now let us see the Hopfield network operation. Let us see continuous Hopfield network operation. Initially consider continuous. Nothing but let us consider sigmoidal activation function is used, whose function is y is equal to f of x is equal to 1 by 1 plus e power minus x, where here x represents summed up value, summed up or net input of input values. So this is the architecture of Hopfield network. Let x1 be the first input, x2 be second input, x3 be third input, which are being fed to the layer, and x1 is passed through a weight of w1, x2 is passed through weight of w2, x3 is passed through weight of w3. Now what is the value at initial condition? Let it be step 1. Let it be step 1. So at step 1, your outputs are nearly 0. So feedbacks are not present. Only inputs are present in feed forward direction. So at first input, only you are having x1, w1. Now, bias, let us consider bias is 0. So only x1, w1 is your xnet. Now, let us consider as you are not having any outputs at initial condition, all the three inputs, which here if you clearly observe, the first input is coming from if you see this, the first input is coming from first output, and second value is coming from second output, and third value is coming from third output. So first input is coming from the first output, second input is coming from second output, third input is coming from third output. Let the fourth input be x1, which is transmitted through w1. And as it is step 1, initial condition, all the three outputs are 0. So what is your net input? x1 net is x1 w1. The same way you will get x2 net, x2 w2. The same way you will get x3 net, x3 w. So you are getting three values, x1 w1, x2 w2 and x3 w3 as the three inputs for the three neurons. Now, as there is no other inputs, the summation is x1 w1. Now you are passing through continuous activation function. Let it be sigmoidal. And here also you are using the sigmoidal activation function, whose the function is y is equal to 1 by 1 plus e power minus x. And here, if you see here, we are having three outputs, y1, y2 and y3. So, this x1 net, x2 net and x3 net are passed through activation functions. And now, we'll get y1 is equal to 1 by 1 plus e power minus x1 net. The same way, we'll get y2 is equal to 1 by 1 plus e power minus x2 net. y3 is equal to 1 by 1 plus e power minus x3 net. These are the three outputs we are getting here. Now, y1 is fed as one of the input to x1 or first input. y2 is also fed as one of the input to the first input. y3 is also fed as one of the input for first input. In the same way, y1 is fed as one of the input for second input. y2 is fed as one of the input for second input. And y3 is also fed as one of the input for second input. In the same way, y1, y2 and y3, all the three inputs are fed as three inputs for third input. Now, again find x net, x1 net. Now, what is your x1 net? x1 w1 plus this y1 is passed through some weight of, let it be w1 dash, plus y2 is passed through a weight of w2 dash, plus y3 is passed through a weight of w3 dash. This is your x net now. The same way, find x2 net. You will get x2 w2 plus y1 w1 dash plus y2 w2 dash plus y3 w3 dash. Then you will get x3 net. x3 w3 y1 w1 dash plus y2 w2 dash plus y3 w3 dash. These are the three inputs, x1 net, x2 net and x3 net after applying recursion process. Now again these are fed through sigmoidal activation functions, and now we are going to generate new values. What is y1? Again 1 by 1 plus e power minus x1 net. What is your x1 net? 1 by 1 plus e power minus x1 w1 plus y1 w1 dash plus y2 w2 dash plus y3 w3 dash. This is your y1, updated y1. Now y2, 1 by 1 plus e power minus x2 net. What is your x2 net? x2 w2 plus y1 w1 dash plus y2 w2 dash plus y3 w3 dash. Next, y3. What is your y3? 1 by 1 plus e power minus x3 w3 plus y1 w1 dash plus y2 w2 dash plus y3 w3 3 dash. These are the updated output values of continuous Hopfield network with a feedback. Now you need to check whether this target value of first input is equal to y1. That is error 1. P1 minus y1 is equal to 0 or not. The same way E2 is 0. The same way E3, which is T3 minus Y3, is satisfying condition of 0 or not. And if the condition is satisfied, okay. If the condition is not satisfied, again you need to perform operation, nothing but Y1, Y2, Y3 is fed as input to the first input, second input and third input. Again you need to calculate x1 net, x2 net, x3 net with updated y1, y2, y3 and then calculate y1 updated, y2 updated, y3 updated. In this way you will perform the operation. Suppose here error is not equal to 0, then you need to find y1 new with updation of weights. You need to change the weights. Whose W1 new? W1 old plus delta W1. What is delta W1? Eta into error into x1. In the same way you need to change W2 new. W2 old plus delta W2. What is delta W2? Eta into error into x2. The same way you need to find W3 new. W3 old plus delta W3. What is delta W3? Eta into error into x3. So with the updated weights you need to find again net values. You need to find new updated output values of y1, y2 and y3 and then you need to again check whether this error value is equal to 0 or not. If the error is not equal to 0, again you need to find weights. W1 new, W2 new, W3 new. If the condition is not satisfied, you need to update this until error becomes nearly equal to 0, not exactly 0, until nearly becomes 0. So this is about continuous activation function or continuous Hopfield network with the using of continuous activation functions like Hopfield sigmoid activation function, or even you can go with the bipolar sigmoidal activation functions like 1 by 1 plus e power minus x minus 1. Now let us see discrete activation function. So what is discrete activation function? If activation functions like step function is used, if x net is greater than or equal to 0, you get output as 1. If less than 0, you get output as 0. This is called as discrete Hopfield network. Now, let us see discrete Hopfield network. So again, let us consider y1, y2 and y3 are 0 at initial condition. So what is your x1 net? x1 w1. What is your x2 net? x2 w2. What is your x3 net? x3 w3. Now, this is passed through step activation function. Let us consider I have got y1 as 1, y2 as 0, y3 as 1. Now the three outputs y1, y2 and y3 are fed as inputs to all the 3 inputs, and then you need to update output values. So again, so what is x1 net? You are getting x1 w1 plus y1 w1 dash. What is y1? Or you can write expression y1 w1 dash plus y2 w2 dash plus y3 w3 dash. So what is x1 w1? You don't know. So simply you write x1 w1. What is y1? 1. 1 into w1 dash. What is y2? 0. So 0. What is y3? 1 into w3 dash. So finally you are getting x1 net as x1 w1 plus w1 dash plus w3 dash. The same way, just find x2 net. x2 w2 plus y1 w1 dash plus y2 w2 dash plus y3 w3 dash. Finally you will get x2 net as x2 w2 plus y1 is 1, so 1 into w1 dash, y2 is 0.